Okay, today we're talking about Chapter 3, Section 6. Oh, excuse me, Chapter 3, Section 6, Polynomial and Rational Inequalities. Alrighty, so we have talked about, polynomial and rational equations, right? Equal sign equations. Now we're going to be talking about inequalities. Okay, so what is an inequality? Well, inequality is, something that is unequal, right? What we're talking about are the signs here that again you've seen before, the less than, the greater than, less than or equal to, and then the greater than or equal to, right? These are all inequalities. They are unequal. Alrighty, so whenever we solve whenever we solve equalities, equations, it's relatively simple, right? So just kind of give an example. If we had something like f of x is equal to x squared. um, no, let's fix that. We'll say x squared plus 4x plus 4, okay, is equal to 0. Well, all we have to do here is we just have to factor, right? We end up with x plus 2, and that's x plus 2 squared, right, is equal to 0. All right, and so that's all I have to do with equalities, right? We just set it equal to 0, and factor, use a quadratic formula, do something, right? Relatively easy. Admittedly, it gets pretty tedious. But once you do a lot of them, you just mindlessly do them. Uh, However, inequalities, unfortunately, there's a little more to inequalities. Okay, and of course we'll talk about that today. But there's a procedure involved, like with everything. Okay, so the procedure we're I'm not going to go over this right now. Instead, I'm going to do example 1, and then I'll come back to this procedure just to kind of show and outline how, I'm not following it 100%, but it's there. Okay, so example 1, we need to solve the polynomial inequality. All right, so it's a pretty little snip for the problem that we're about to do. So what we're going to have to do here is we need to move everything to one side. So I'm going to go ahead and rewrite this by moving everything to one side. Something like that. All right. And then next we're going to factor. Now, how do we factor this problem? It's not it's not one of those super duper easy ones. Once you do this a lot, you probably know the factor. But just to be super duper thorough, let's go ahead and do the AC method just to refresh our memories. Okay. So the AC method. What was the AC method? Well, it was. Let's put it over here. Let's put it in yellow. 2x squared. No, let's do this. Okay. The AC method, if you recall, is we look at the A value and the C value. Okay. The A value being 2 and the C value being negative 15. So let's just put that down. So AC method, okay, is a 2 times, and we're just gonna deal with the positive 15, right? Just for right now. 2 times, no, let's go and put negative 15 to be thorough. All right, kind of more or less take the absolute value of it, and then it's 30. Okay. Man, run out of room here. Let me fix this a little bit. Okay, so I'm gonna be erasing this later, so I'm just gonna take up a lot of space here. AC is 2 times negative 15. And again, I'm gonna go and put negative 15 here. Okay. But I'm going to say equal to 30. And here's why. Okay, so essentially we're going to be taking the absolute value of it because I want the positive component. And here's why. If I were to say, what are my factors of negative 30? Okay, well, you could say 1 times negative 30, or you could say negative 1 times 30. And I want to go ahead and not have 2 of every single factor. So that's why I just say, just take the positive component of it, right? So we're just going to look at the positive 30. And now we are going to account for the negative sign here in a moment, but let's just look at that positive 30. Okay, so looking at the positive 30, what are my factors of it? Well, 1 times 30, as we said. Looks like 2 times 15, 3 times 10. And again, if you notice, I just go 1, 2, 3, 4, 5, 6, all the way down. Okay, that makes it easier, and I can keep my ideas lined up. 4 doesn't go into it, and then we have 5 times 6, and then 6 times 5. But I've already got 5 times 6, so I don't have to do that now. Okay. So now what I'm going to do is I'm going to ask ourselves, okay, so of these 4 factors, which one, when you add or subtract them together, will get you a positive 1, right? Because that's a positive 1 in front of the x, right? Well, obviously the 5 and 6, right? A positive 6 and a negative 5, right? 1 and 30 can never get you 1. I mean, you can get 31 and 29. 2 and 15 get you 17 and 13. 3 and 10 will get you a 13 and a 7. But 5 and 6, you can add or subtract them together to get you a 1. And like I said, it's a positive 6 and a negative 5. So what we're going to do is we're going to rewrite this equation. It's 2x squared. And then we're going to say plus 6x and then minus x. And then minus 15. And that's greater than 0. Now, the whole point of this is to factor by grouping. We've talked about factor by grouping before, so I'm going to just essentially split this down the middle, right? And then what can I factor out on my left side? Well, it looks like I can factor out 2x, and what remains would be an x plus 3. Did I do something wrong there? 2. I don't know. Let's just proceed here. And then, oh, that's what I did wrong. Okay, good. It's a minus 5x. Sorry about that. Yeah, I knew something didn't look right. Okay, there we go. A minus 5x because I need to factor out looks like probably a negative 5. So we're going to factor out a minus 5 here. And what remains? An x plus 3. Okay, so this was actually a happy accident. Okay, the happy accident being, I said, did I mess something up? Did I write something down wrong? Because if you recall from factor by grouping, I need to make sure that these two are the same. And if you do it correctly, they will be the same. And of course, when this was just simply an x, I couldn't factor anything out of it, and I would have an x minus 15, and so in the parentheses would not be the same. So that was that happy accident I was just talking about, and we want to make sure that they are the same. Okay, so once I did factor by grouping, I can now rewrite this as 2x minus 5 and x plus 3. It's greater than 0. Okay. Alrighty, so I'm going to go ahead and erase this work up here. Alright, if you missed it, just go back and rewatch it. But I'm going to erase it so I can have some room right here. And there we go. Alrighty, so with this, okay, what are my x values? Well, I've got x is equal to, looks like it's going to be a positive 5/2, and x is equal to negative 3. Now, those are not the solution. Okay, what we're going to have to do is something that I bet you don't feel like doing, because I don't feel like doing it ever. And that's creating a number line. Okay, like so. Now, on this number line, I need to have some boundaries. These boundaries are going to be my x values here. Okay. Now, you could, if you wanted to, and I honestly I don't suggest it, but you could start here at 0 and then go 1, 2, 3, 4, and 1, 2, 3, 4. So that's negative 4. That's positive 4, 3, 2, 1. You could do this. I don't suggest it. Why? Because it doesn't really matter what the tick marks are. What matters is that you have the tick marks associated with your x values. So we've got 2, right? 5 halves and 3. So this would, we're just going to call this one 5 half. Ooh, never mind. Yeah. We're going to call this one -3. Sorry, -3. And we're going to call this one 5 halves. Okay. So I mean, do you understand what I mean? You don't technically have to have the 0 tick mark, 1 tick mark, whatever. You just need to have tick marks that associate with these, and just make sure that they're in order, right? -3 comes before 5 halves. Okay. So the whole point of doing that is because now we're going to, these are our boundaries, right? So the boundaries are located at -3 and at 1/2. So let's, what is the interval over here to the left of that dotted blue line? Well, the interval is going to be from -infinity to a -3, right? Not including -3 because, that's our boundary, so we put a parentheses. What is this middle one? Well, it's going to be a -3 to a 5 halves. And then what's this one over here? Well, it's going to be a 5 halves to a positive infinity. Okay, so again, there's a number line, and on either side of these dotted lines, these are intervals. So what's important about these intervals? Well, what I'm going to do is I need to pick a number. I'm going to need to pick a number that's inside these intervals. Now, the thing is, I suggest picking the smallest number that you can. And if you have a 0 or a 1 available to you, use it. Okay, so from -infinity to -3, well, -1 trillion is in that interval, right? But the thing is, I'm going to be taking that number and plugging it into these x values. So we obviously don't want to use -1 trillion. Instead, let's just use a -4. Okay. For this interval from -3 to 5 halves, I said that if you have a 0 or 1 in the interval, use it. Well, if I have a 0 and 1, I'm going to use the 0 because multiplying anything by 0 is so much easier, right? And then from 5 halves to infinity, well, 5 halves is 2.5, right? So let's just use the number 3. So again, I got my x values, and then from there, I made those x values my boundaries, right? And then from the boundaries, I know that I had intervals inside these boundaries, and then I chose a number in the interval. Okay, and the whole reason why is because I'm going to be plugging these numbers into this equation right here. Now, before we begin the process of plugging it in, we know that if we have a positive times a positive, that's going to be a positive. A positive times a negative is going to be a negative, and a negative times a negative is going to be a positive. Right? These are math rules we're familiar with. So we're going to be using that idea for this, right? So we don't even have to figure out if the number, we don't even have to figure out what the number is. We just have to figure out if it's positive or negative. So what do I mean by that? Well, let's plug in a negative. Let's recircle this here. If we plug in a -4 for x here, -4, so maybe make it larger. Let's make it red and larger. Okay, so if we put a -4 here and a -4 here. Okay, well, 2 times a -4 is a -8. A -8 minus 5 is a -13. But the thing is, I don't even have to know that it's -13. All I got to do is I got to know that, okay, this is a negative number. This term right here is going to be a negative number. Okay, and then I've got a -4 plus a +3. Okay, well, -4 plus a +3 is a -1. And again, I don't necessarily have to know exactly what it is. It does help, obviously. But I know that -4 and a +3 gives me a negative number. Okay, so now it's going to be a negative times a negative. And a negative times a negative is a positive, and a positive number is indeed greater than 0. Okay, now if you missed that, we have 2 more examples there. Or you can just hit rewind. So if I plug in a -4 into x, then my inequality is a true statement. Okay, now let's plug in a 0. Okay, if I plug in a 0 in for here and for here, well, 2 times 0 is 0, and I got a -5. So this term is a negative. 0 plus 3 is 3, and then that term is positive. Okay, let's see, the entire term is positive. And so I've got a negative times a positive, which is a negative number, and a negative number is less than 0. So this interval does not satisfy that inequality. Let's actually erase all this first before I put the x there. Does not satisfy the inequality. Okay. Lastly, we have the 3. So if we plug a 3 in here and a 3 in here, all right, 2 times 3 is 6. 6 minus 5, well, that's 1. Okay. And again, that is a positive number. 3 plus 3, well, that's a 6, which is a positive number. And so we have a positive times a positive, which gives me a positive number. Okay. And so this interval does work. And one moment. All right, sorry about that. Let's see. So, all right. So where are we at? We have two intervals that satisfy the equation, right? And again, let's actually go back and get rid of all that red there. So these two intervals work. Negative infinity to a negative 3 and a 5/2 to infinity. And, well, that is the solution to this equation. The solution, right, is not going to be, so if we go back to, well, we didn't actually give I erased it, but our equality problems, the solutions are just, numbers, right? An actual value. Well, the solutions to inequalities is going to be intervals. Negative infinity to negative 3 unioned with 5/2 to infinity. Okay? And that is, again, that's the solution. All right? It's long, it's tedious, it's probably not something that you're, pretty excited to do, but it does need to be done. Okay? So let's do another example. Okay, so it's not moving. Okay, so example 2 there. Oh no. Okay, so new page. Alrighty, so in order to begin this, again, we're going to put everything on one side. So let's go ahead and put everything to the left side here. So we're going to have a 4x squared, and then plus 2x, and then minus 1 is less than or equal to 0. Okay, so, and then kind of cheated here. I see that we're going to use the quadratic formula, but let's go back to example 1 here. You also could have used the quadratic formula for this. All right. Now, and honestly, I probably would use quadratic formula more often than not, mainly because my own personal rule is, if I cannot factor the problem in my head within 3 to 5 seconds, I just go straight to the quadratic formula. It's the nice catch-all. You're going to get your solution, and you don't have to do any sort of factoring. With that said, I'm gonna cheat a little bit, if that's okay, because I mean we've done the quadratic formula before. Hopefully you can forgive me for cheating a little bit here. But my solutions are, looks like a negative 0.8 and a positive 0.3. Okay, so again, I mean all we're doing here is we moved everything to one side, and then we're going to get our x values. Okay, and our x values are negative 0.8 and 0.3. So let's go ahead and put that up here. So we've got equal to a negative 0.8, x is equal to a 0.3. And again, this is just a quadratic formula, something that you have seen before, something we've done, something we've covered in this class. All right, so again, from here, we're going to create a number line. Okay, so we create a number line. And again, it's not imperative, and maybe this example might really show you what I mean. It's not imperative that you do 0, 1, 2, 3, -1, -2, -3. It's not imperative that you do that. Okay, and this is a really good example because -0.8 is right here, and 0.3 is about right here. Okay, and so you know it's kind of mushed together. Instead again, it's just easier if we do this. We'll just put, I don't have to do it twice there. We'll put -0.8 here, and we'll put 0.3 here. Okay, it doesn't matter where they're placed. It's just it's the concept. It's the idea that matters. Okay, so we'll cut up at the boundaries. Boundaries are blue. Okay, so my boundaries are going to be blue. Okay, my boundaries are just basically where those are, where those x values are. And so we're going to put our intervals. Okay, well, what is the interval from -infinity to -0.8? Well, it's just going to be -infinity to a -0.8. And from here, we've got from -0.8 to 0.3. Sorry, 0.3, 0.3, there we go. And then from 0.3 to infinity. All right, and then sorry, I keep going back and forth because I like to be consistent. I don't know, it's a thing of mine. So from -infinity to -0.8, what's a nice number that sits in that interval? Okay, well, it's just -1. Right? -1's pretty good to me, right? I mean, you could use -22, but I mean, you got to plug that number into these x values. Okay. From -0.8 to 0.3, well, I've got 0 available to me. I'm going to use it. And then lastly, from 0.3 to infinity, I've got a 1 available to me. I'm going to use it. If you have a 0 or 1 available, always use it. Now this particular one, I have a -1 and a 0 and a 1 available to me, so I used it. Okay. Now I'm going to I'm going to be pulling out my calculator. I don't actually need a calculator for this. Let's not actually use a calculator. How about that? Okay. Because it's pretty easy arithmetically. So if I plug a -1 in right here and a -1 in right here, okay. Well, let's do the arithmetic here. Again, PEMDAS, we're going to square the -1 first. So -1 squared is a 1. 1 times 4 is a 4. Okay, so that first term is going to be a 4. So we'll just kind of put it down here. That's a 4. And then plus 2 times -1 is a -2. So -2 minus 1. Okay, so we have 4 minus 2 minus 1. 4 minus 2 is a 2. Minus 1 is a 1. Is 1 less than or equal to 0? Well, no, right? Because I mean 1 is a positive number, so that is not a true statement. So what that tells us is that this interval does not work. Now 0 is super easy, and this is why we use 0, and of course 1s as well. We just simply plug a 0 in here, a 0 in here. Well, those just cancel, right? Because I mean 0 times anything is 0. And then and then we have a -1 is less than or equal to 0. Well, I mean, that is a true statement. -1 is indeed less than or equal to 0. So that is a true statement. So there it is. Okay. And then lastly, we have a 1. Well, let's plug the 1 in. 1 here, 1 here. Same thing, right? 1 squared, PEMDAS, right? 1 squared is 1. 4 times 1 is 4. 4 plus 2, because 2 times 1 is 2. 4 plus 2 is 6 minus 1. Well, that is a 5. Okay. Is 5 less than or equal to 0? No, it's not. So this interval does not work either. Okay. So my only interval that works is from -0.8 to a 0.3. Okay. So let's go and put this. Let's put the solution up here real quick. -0.8 to 0.3. Okay. Now that's not the solution. And notice and I forgot to say this on the previous example, and I'm really sorry, but notice how on the previous example, I used the parentheses. Well, obviously on infinities, you always use parentheses, but on -3 and the 5/2, I use the parentheses. That's because this particular problem was just a strictly greater than. Okay, so we do use parentheses. However, this is a less than or equal to. So we're going to use brackets. And there you go. Okay. Whew. So that's that. Not the hardest, not the easiest. So let's go to the last example for today. I would definitely say today is more of a shorter day, but it's just one of those days that, I mean, it's not easy, right? Oh, I said I was going to go back and revisit our procedure here. Okay, so our procedure. Okay, so and again, obviously I followed this procedure, but I didn't do it. I didn't do step 1, step 2, step 3, and of course you can if you want to. But to me, it's just extra stuff for you to memorize. And I've been there. I've been in your shoes. I don't want more things to memorize. But if I could have like an organic flow to it, it makes it a lot easier. Okay. So obviously what we did was we moved everything to one side, right? And then what we did was we solved the equation for f of x equal to 0. And in one example, we factored. And in another example, we did the quadratic formula. Although we didn't technically do the quadratic formula in here. I kind of cheated, I know. But we know how to do the quadratic formula. And there's really no need for me to show you a plug and chug, something that you've done before a lot. All right, we did that. And then we had our boundary points, and we had a dividing line, my nice dotted blue line. And then we choose a representative number called a test value within each interval, which we did, right? Between -infinity and -3, we had -4. Of course, we had the test interval down here in yellow. Where we go. And of course, we decided, are the statements true or are they false? And I put a big old check mark or a big old X to say if they're true or false. And then, we're pretty much done. So to reiterate, I don't technically follow the procedure. Verbatim, I guess, but we did. We did. All right, and the last one the last kind of inequality we're gonna deal with are buggers. They are you're not gonna like them, I promise. But here's the thing. You have made it this far in the semester. We're almost at spring break. We're almost at the midway point. And I'm pretty sure spring break is actually a little bit later, at least at this institution than most. So well, you know what? Sometimes it's really hard for me to collect my thoughts. We're still pretty much at that midway point, right? You've made it this far. You can certainly finish this up. For many of you, this is going to be your last math class. Finish strong, okay? But what I was going to say is, this is a bugger. It's gonna be rough. It's gonna be hard, but I know you can do it. So let's dig in, okay? So let's go ahead and do the thing where we said where we get everything to one side. Okay, so we're gonna get everything to one side. We get everything to one side, and that was the easy part. Okay, next up, what we're gonna have to do is we can't just solve this side. We can't just solve this left side here like this, right? Because what are my boundary points? Well, I mean, looking at it like it is, it you don't necessarily have any. I mean, you do, but you have to do some manipulation. Let's go back real quick and look at uh, our polynomials here. Okay, so if we look at this, notice how it's in every case it's f of x. It's greater than or less than or greater than or equal to or less than or equal to 0. It's just a singular f of x. Unfortunately, we have two. We kind of have an f of x and a g of x. We have two terms here. That's not good. So what we're going to have to do is we're going to have to manipulate this equation into a way where we turn it into one equation. Okay? So how do we do that? Well, we're going to have to get a common denominator. Okay? So we're going to have to get a common denominator and then combine the rational inequalities, or well, the function, I guess. So what is a common denominator? Well, one of the denominators is x plus 3, and the other denominator is a 1. So obviously, there's a 1, right? It's an implied 1. So obviously, what we're going to do is get a denominator of x plus 3. Well, how do we do that? Well, lucky for us, it is kind of easier, right? So we're going to say x plus 1 over x plus 3. We have to get that common denominator of x plus 3. So check this out, okay? I can say x plus 3 over x plus 3, all right? And then we have the 2 in front of it. And that's written kind of messed up. Let me correct that just a little bit. Well, we'll just start from top instead. Okay, so what did I do here? Well, the whole point of this is to get a common denominator, okay? So now we officially have a common denominator, okay? Well, but we also have to account for the 2 there, right? And of course, the minus is here. We also have to account for the 2, okay? Well, I did something very clever here, right? What I did was I basically said 2 times 1, right? Because x plus 3 over x plus 3, well, that's 1, right? And of course, we can cancel it out, and we have that single 2 left over, right? So I did something clever here to get a denominator of x plus 3. So what's the cleverness? Well, I just said it. Now, the show has actually been off the air for a couple years, and time is a little bit different the older you get. But there was a show a couple years ago called The Big Bang Theory. You've probably seen, you've probably heard of it. But there's a character on that show. His name is Sheldon, and he always overcomplicates things. And so here's my Sheldon moment to overcomplicate this. If I were to be Sheldon and somebody said, "Hey, Sheldon, how old are you?" Well, I would say, I'm just feeling feisty. I would say that I am 35 times the quantity of x plus 3 over x plus 3 years old. Okay, and then the laugh track will go ah ha 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 ha, right? But it was just a really complicated way to say that I am 35 years old, right? I mean, it makes sense. It's logical. You don't necessarily make problems like this, but you have to do something clever in order to get a common denominator. Now, I am quite positive I over-explained that, but it is what it is, and this is why I tell you to crank the speed up to 1.5. Okay. But anyways, and of course this is greater than or equal to 0, right? So these two inequalities are the exact same, right? Obviously they're written different, but they're the exact same. So now we can actually we can actually work with this, and we can do some arithmetic. Okay, so let's look at let's look at just the left side here. Okay, obviously we have the inequality of greater than or equal to 0. But let's just look at the left side here. Let's smush this in a little bit so we can actually work on it. Okay, we'll just erase that then. Okay, all right. So again, just dealing with the left side here. We have that common denominator of x plus 3. That's exactly what we wanted. Now we have to look at the top. We have x plus 1, and then we have a minus 2 times x plus 3. Okay, well, let's just go ahead and distribute that 2 times x plus 3. So it's going to be a minus 2x and a minus 6. Okay. All right, and then if we combine the like terms, it looks like it's going to end up being, and we'll just put it up here. It looks like we have a positive x and a negative 2x, so it's going to be a negative x. We have a positive 1 and a negative 6. We're going to have a minus 5. That's over x plus 3. And that's supposed to be greater than or equal to 0. Okay. So we now have a singular function on the left side. Okay. But we're not done, but we're very, very close now. Okay. So previously, we just had, simple polynomials, right? Not rational polynomials, no fractions, just simple polynomials, okay? Well, we had these simple polynomials, and it was pretty easy to figure out the boundary. Now, it's actually pretty easy to figure out the boundary to a rational polynomial, okay? And that simplicity is I'm just going to um, solve my numerator for 0 and solve my denominator for 0. And that's it. And of course, we can do this in our head, right? The numerator is x equals -5, and the denominator is x equals a -3. And again, I just basically set those equal to 0. Negative x minus 5 is equal to 0. I add 5 to both sides, and then I multiply both sides by -1. So we have a -5, and this, is pretty easy, right? A -3. So a -5 and a -3. And again, it's not necessary to write the tick marks. Just know that, -5 is smaller than -3. And these are my boundaries. So let's put our nice dotted blue line here. Just pick that dotted one. All right, so these are my boundaries. And let's make intervals. All right, so this interval will be from -infinity to a -5. This is going to be from a -5 to a -3. This is going to be from a -3 to infinity. Okay, and let's choose a number in these intervals. Well, from -infinity to, I keep on forgetting, oh, that big old gap. From -infinity to a -5, well, we're going to have to use -6. Not excited about it either. From -5 to -3, we're going to use -4. And then from -3 to infinity, I'm going to use 0. 0 is always good. Okay. So, similar to how on the previous examples, I would, well, at least this one, I said, I did positive times a negative is a negative, or positive times a positive is a positive. I'm going to be using that same sort of idea, but we're doing division now. Okay, so I'm going to be plugging the numbers in the numerator and the denominator over here, and saying, okay, positive divided by positive is a positive, a negative divided by positive is a negative, and so forth, right? So here we go. We're going to plug in a -6. A -6 is a +6, and a 6 minus 5, well, that's positive. That's a positive number, right? 6 minus 5 is 1, but that's a positive number. And then in the denominator, we have, if we plug in a -6 down here, -6 plus 3, well, that's a -3. That's a negative. Well, what is a positive divided by a negative? Well, it's going to be a negative number, and a negative number is not greater than or equal to 0. So this interval does not work. Okay. Next up, we have a -4. Well, again, kind of same thing. A -4, it's a +4. Again, looking back here, a -4 is a +4, and then a +4 minus 5. Well, that's going to be a negative number in the numerator. And then in the denominator, we have a -4 plus 3 is a -1, which is also a negative number. A negative divided by a negative is a positive, and a positive number is greater than or equal to 0. So this interval works. And then 0, again, 0 is always my favorite, right? So if we plug in a 0, well, we have a 0 here, a 0 here, so we're basically just looking at these numbers here. Well, again, you can do the arithmetic, it's -5/3, or you can just say, okay, that's a negative in the denominator, a negative number, doesn't matter what it is, it's a negative. And the denominator, it's a positive number, doesn't matter what it is, it's a positive. A negative divided by positive is a negative number, and a negative number is not greater than or equal to 0. So this interval does not work either. The only interval that does work is from -5 to -3. And it is in greater than or equal to, so I will use a bracket, -5 to a -3 bracket, and that's my answer. Okay, and of course I ran out of room. It looks pretty awful there, but I mean, it is what it is. All right, and that does conclude today's lecture. Again, it's short, but it's kind of tedious. It's kind of all right. Email me if you have any questions.